understand. Whoever missed. Okay. So we have started, we plan to start EMI, but the problem is for EMI, you need magnetic effects, the fundamental of magnetic effects. That's why we switched over to the chapter magnetic effect of electric current. And we started that last class. So we did a derivation, how to find a magnetic field for a current carrying conductor from a distance. Is it so, Harsh? Anything else we studied?
sir, ये सभी पढ़ा था.
So today we are going to study a most important topic, Lorentz force. Lorentz force. What is this force? Anybody? Have you heard about this force?
No,
Have you heard about this force? Lorentz force is nothing. Whenever a charge object travels in a electric and a magnetic field. Electric field is given by E and magnetic field is given by B. It experiences a force. Okay? It experiences force. The net force acting on the object, the charge object, positive or negative, is called Lorentz force. Clear? So we said that there is an electric field and there is a magnetic field. So the total force F net will be Fe plus Fb or Fm. Some say Fm, some say Fb. Fb means magnetic field, force due to magnetic field. M means force due, B is magnetic field, M also magnetic field. Some book write M, some write B. I think your book writes M, I guess. Okay. So what is Fe? If you study electrostatics, when we come to the chapter, we will study electrostatics is nothing but Fe is equal to QE. And what is Fb? Here Fb is nothing but Q into V cross B. V cross B. What is V? V is the velocity of the charge object. B is the direction of the magnetic field. Where the charge object is going. So last class I taught you that if the magnetic field is going inside, then we represent it as a cross. Yes or no? Yes. So we saw that when I was having a current carrying conductor, current apply the screw rule. So here the magnetic field will be cross. Yes or no? And this side it will be dot. Yes or no, Rishabh?
Yes, sir.
How? Apply the screw rule. Apply the screw rule. Right hand thumb rule. Put your finger this side and curl your fingers. So when you curl your finger will hit on the plane, on the paper. That means the magnetic field is going inside and coming outside like this. I taught you in last class. Yes or no? And if it is downward direction, then your magnetic field will be opposite. You will get dot here and cross here. Yes or no? All this is already taught. Okay. So if the current is going in this direction, which current are we talking about? Conventional current or electronic current? When you talk about current, which current, what are you talking about? Conventional current or electronic current? Guys, come on. 10th standard. Conventional current, right?
Yes,
Conventional
sir.
current. That means electronic current is which side? Downward direction. Yes or no? That
Yes,
means
sir.
the electrons are going in this direction and protons are going in this direction. So if you are taking that protons are this direction, that means the velocity of the positive ions are upward direction. Magnetic field is where? Inside. Yes or no? Then how is the force? We will come to
Yes,
that.
sir.
Law. We will come to that
Yes,
law.
sir.
That means left hand rule. We will study. So this talks about the magnetic field, talks about the vector formula. It talks about the direction of the force. If the magnetic field is in a particular direction, if the B is particular direction, then which direction the the body or the object will get deflected. Is it clear? Till now you understood?
Yes,
So
sir.
if somebody asks you what is Lorentz force, you say the net force acting on an object where whenever it is there in the both presence of electric field and magnetic field. If there are no electric field, then what will happen? Your Lorentz force is what? Only FB. Why? Because FE is what? 0. There is no electric field, only magnetic field is there. Are you clear?
Yes, sir. Yes, sir.
Yes, sir.
When you talk about the formula Q equal to V cross B, so that means there is a, that means we will talk about because this chapter will study about only FB because force due to magnetic field. Electric field will not study now. So our formula is what? Q into V cross B. Q is what? The charge of the proton or the electron. So what? It is a coulomb. Yes or no?
Yes, sir.
So what is this? Is a scalar? This is only a value.
Yes, sir.
Scalar. It's not a vector. But V and B are what? Vector. So whenever you write, this will also be a vector. If you do not write, you will lose marks. But if I want to find out the magnitude of this vector, then it will be Q D B sine theta. And what is this theta? This theta is the angle between the velocity vector and the magnetic vector. Is it clear?
Yes, sir.
So just tell me the formula. If the B is this side, magnetic field is this side, and the velocity is traveling in this side. So will there be any force or not? Both are traveling in the same direction. So what will be theta?
0.
0. If the theta is 0, then sine theta is
0.
0.
Then what will be any? Will there be any force?
No, sir.
That means if the velocity of the particle and the magnetic field are in the same direction, then your FB will be 0. Is it clear?
Yes, sir.
Same. One more we will study. B is this side. Velocity is this side. So what will be? What is the value of FB? 0 or any value? What is the angle between this both vector? 180 degree.
180.
180 degree.
So what is sine 180 degree? 0. Again, it is 0. So what do you learn? That if the velocity vector and the magnetic vector are in the same direction or opposite direction, the FB is always 0. Note it down. Yeah, Ganesh. किसको Tanak, are you able to understand, beta?
Yes, sir.
That's okay. Yours in a demo class. So anyway, you are 11th standard. This is 12th. So are we clear, guys? If the velocity of the object and the magnetic field are in same direction or opposite direction, then the FB will be 0. Is it clear?
Yes, sir. Clear.
Yes, sir.
Given anything, whatever be the theta, you can find out the value of the magnetic force. Except 0 or 180, you will have a value. Is it clear?
Yes, sir.
Yes, sir.
Yes,
That is the
sir.
Lorentz force. Okay. So now what? So you can write a sentence. For a moving charge, force due to magnetic field. For a moving charge, force due to magnetic field depends on the magnitude of charge. Depends on the magnitude of charge and cross product of velocity vector and magnetic field vector. Clear?
Yes, sir.
Yes, sir. Yes, sir.
So how will be the, this is a plane. Sorry. This is the V, this is the B, and force will be this way. Clear? Like a XYZ plane. X, Y, and Z, where they are mutually perpendicular. Agree with me? Agree with me? But this may be perpendicular, this may not be perpendicular. But F is always perpendicular to B and B. But V and V are may not be perpendicular, may be perpendicular, may not be perpendicular. You might have like this. You might have value like this, where B and V are not 90. There can be like this also. There can be like this also. But the angle between the force F and B, F and V is always perpendicular. But the angle between the F, B and V may be perpendicular, may not be perpendicular. Is it clear? Is it clear? Harsh?
Yes, sir. Yes, sir.
Yes, sir.
Clear?
Yes, sir.
The angle between the velocity vector and the magnetic field vector may not be 0, may not be 90, it can be anything. But the angle, the F and B, F and V are always perpendicular. Is it clear? So what do we derive from this? There are 3 points we'll derive. First point, write down. FB never does any work on a moving charge. Second, FB can never affect the speed of the moving charge. So what it will affect? If not speed, then what it will affect? Direction. Clear? Clear? It will affect the direction, not the speed. Speed will not be affected. Only the direction will be affected. Is it clear?
Yes, sir.
May or may not. Depends. May or may not. But the speed is never affected. Speed is never affected. It may change their direction. Depends. May or may not. We might have scenarios. Very, very important. Clear?
Yes, sir.
Yes, sir.
So let us come to the
Yes, sir.
right hand thumb rule, which is very, very important. Fleming's right hand thumb rule. Left hand thumb rule. What does it say? Has anybody heard about this or completely new? Maybe you would have studied in your.
No, sir. We have studied in 10th standard.
10th
Yeah.
standard, sir.
Any idea what is that?
The thumb indicates the current, and first finger indicates the force, and middle finger indicates the magnetic field.
Okay. So I will draw. This is the thumb, fat one. This is the forefinger, and this is the middle finger. Whatever hand, I don't know how to draw. Okay. So the thumb indicates the force. Okay, force. The forefinger indicates the what? Magnetic field. Okay. And this one, middle finger, represent what? Current. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
And
Yes, sir.
obviously, this is XYZ. Huh? You are seeing like this, but it's actually XYZ. XYZ. So, can I take a scenario? I have magnetic field like this. What do you mean by that? Rishabh will tell. When I say magnetic field is crossed, what do you mean by that? What do you mean by that? What is the direction of magnetic field? Yes, inside.
It's outside, right?
Going
Yes,
inside
inside.
the plane. If it is dot, it is coming outside the plane. Clear? So magnetic field is this side. Clear? The velocity is this side. So what direction will be the force? Please try. Apply the Fleming's left-hand rule and try. Apply.
So what do you have to find?
You have to find the direction of the force, deflection. Which side will be the force applied? How will the velocity be? That means that there will be deflection of
And
the
that
velocity.
arrow is current.
Which one? Arrow is not current. Yeah, this is the current. Yes, of course. Current. Positive ions. No, we are talking about the. We are talking about the. We are talking about the positive ions. Just think 2 minutes. I'm getting a call. Yeah. So which direction
So
it
the
will
force
be?
will come outside.
Outside. How? Your
So the current is going upwards.
align your forefinger across magnetic field. So you have to put your forefinger magnetic field inside. Okay. Then it will be like this. So can you? I don't know. Basically like this. Your finger will be like
The
this.
current is going upwards.
Yeah, current is going upward. So current is this one.
So the force will come outside, right?
No, it will be this side. It will be hand will be. This will be a forefinger. Okay. Your middle forefinger will be inside magnetic field. अंदर की तरफ. ठीक है? And upward will be top will be middle finger. Obviously thumb will be this side, no?
Sir, middle finger is the current, right?
Current is this side. Upward, upper. Put your finger, put
So
your
it
palm.
will.
Put your palm opposite. Put
Sir,
your
मेरे को तो
palm.
बाहर आ रहे हैं.
बाहर कैसे आएगा? थंब तो बाहर आएगा ना? ये देखो. On your cameras.
Sorry.
No, it's difficult. See. On your cameras. देखो. Keep your finger like this. Keep your finger like this. Okay. So this one is inside the plane, going inside. That is clear? Clear हुआ कि नहीं?
और कंफ्यूज हो रहे हैं.
क्यों कंफ्यूज हो रहा है? मुझे ये समझ में नहीं आ रहा है. Keep your hand like this, no? Hey guys, please on your camera, no? I am switching on my camera. Why you not keeping on a camera? How will I know what you are doing? Switch on your camera, no? What are you doing?
Sir,
Put your finger like this. Put your finger like
but
this.
current is going upward.
Current is going which word? Upward. Yes. And this is going
But the
inside.
magnetic field is right.
Going inside. No, it is going inside. It's the plane.
Yeah.
So which side is the force? Force is this side. Towards your left side. Put your finger. Check. Put your finger. Yes. तेरा आवाज नहीं आ रहा हर्ष.
हाँ सर अभी
समझा? Everybody understood? ऋषभ तेरे को स्पेशली बोलना पड़ेगा क्या?
Yes, sir. Understood.
क्या मतलब बाथरूम में बैठ के पढ़ रहे हो क्या? ऑन नहीं कर सकते?
सर लैपटॉप को कैमरा नहीं है.
लैपटॉप कैमरा नहीं है. तू क्या कर रहा है? मुझे कैसे पता चलेगा?
लैपटॉप में लॉग इन किया.
Clear?
Yes, sir.
Is it
Clear.
clear? Now tell me, same thing, if the velocity is this side, current is this side. Okay, which side will be the magnetic force? This side. Obviously, no. magnetic field is not changing. Only the velocity is changing. So this will be the force. Clear?
Yes, sir.
Clear or not?
Yes, sir.
Yes, sir. Clear.
Yes, sir.
Yes, sir.
Learn to apply. Next, this Rishabh will tell me. Dot. So how is the magnetic field, Rishabh?
Sir, outside.
Very good. Velocity, current is this side. So which side will be the force?
Sir, left side.
Left side. How? How left side?
Sir, outward, na?
Yes. Outward. Magnetic field is outward.
Yes.
Yeah, left is correct. And if the current is this side, then it will be this side. Clear?
Yes, sir. Clear.
So learn to apply. One more method you can also use palm method. Palm method. What does the palm method says? Anybody? What is this palm method says? Palm method says your finger, thumb is I, this side, top side. Fingers will be B and force will be upward. Force will be across the palm. Is it clear?
Yes,
Is it
sir.
clear? Same thing. Put the palm. Use here. So if you put the palm here, your palm fingers will be the fingers. Keep your palm like this. So fingers will be pointing in. Fingers will be pointing outward. Okay. Fingers will be pointing outward. Yes or no?
Yes, sir.
And fingers will be pointing outward. Sorry, inward. Oh, sorry, outward. No? I'm sorry. Finger will be pointing outward. And no, go by this method only. You don't get confused. Even I am also getting confused. Use this method and solve problems. Is it clear?
Yes, sir.
So Fleming's left-hand rule is very, very important. Okay, exam point of view. Any method you use one method. Don't use multiple methods. Otherwise, you'll get confused. Clear?
Yes, sir. Clear.
Okay. So next we'll
Sir.
see. Yeah.
Sir, may I leave?
Yeah, you may leave.
Thank you, sir.
So now we will study about what is the if BF equal to QVB. This is what the magnetic. This is the magnitude. Clear? The magnitude. Okay. Then what will be your B? Your B will be what? F by QV. Agree with me?
Yes,
Agree
sir.
with me or not? What is the force? What is the formula of force? Newton. Agree with me?
SI unit,
Yes.
na?
Yes. Q का क्या होगा? Q का होगा क्या? Coulomb.
Coulomb.
And what is the velocity? Meter per second. So second will go up Newton per second cubic meter. Clear?
Yes, sir.
Yes, sir.
So how can we find the magnitude dimension? How can we write? How can we write in this way? Anybody? Are you aware how to write?
No, sir.
Why? You don't know how to find dimension of B? What is the dimension of F? Mass into acceleration. Yes or no?
Yes, sir.
What is mass? Mass का क्या होगा? M1, L0, T0, A0. Acceleration क्या है? मीटर पर सेकंड स्क्वायर. मतलब L by T2. तो इधर क्या आ जाएगा? L T minus 2. Yes or no? T ऊपर जाएगा तो -2 हो जाएगा ना?
हाँ सर।
तो एफ का कंबाइन क्या होगा, m1 l1 t माइनस टू a0, ये डायमेंशन है एफ का। क्लियर?
ml t to the power -2।
सॉरी,
मैंने सर वही डायमेंशन ही बोला।
गुड। Q का क्या लिख सकते हैं, Q इज व्हाट, IT, करंट इनटू टाइम, यस और नो, मतलब A1 इंटू T1, यस और नो यार, व्हाट इज Q, I इक्वल टू Q बाई T, तो Q इज IT और नॉट?
Yes sir.
यस सर।
तो I क्या है, एम्पियर, A1, T क्या है, T1, तो Q इज A1 T1, तो आपको ये मिला M1 L1 T माइनस टू A बाई 0 डिवाइडेड बाय A1 T1। क्लियर? तो बचा क्या, वेलोसिटी, वेलोसिटी क्या है, मीटर पर सेकेंड, दैट मीन्स L1 बाय T1, if you take it up it will be LT minus 1, agree with me?
Yes.
So M1 A1 will go up, it will become what, A minus 1, agree with me? T1 will go up, T1 T minus 1 to 0, so it will become what, T minus 2, L1 L will again L become 0, so this is the magnetic dimension, M1 L0 T minus 2 A minus 1. Clear?
Yes sir. Yes.
Write down, please write down, very very important from lot of exam point of view. कैसे निकालते हैं, हर्ष समझा?
हाँ सर, पर थोड़ा वीडियोस देख लूंगा और
एक काम करो, लॉग इन करो फिर से, प्लीज लॉग इन अगेन, ऑल ऑफ यू।